Video, we are going to be looking at some moles calculations. Once we've done all the other videos in the calculations, the quantitative chemistry playlist. So this one goes over a whole bunch, and it especially uses ones that are found on Carousel Learning. So if I or your teacher or whoever has set you some questions from Carousel Learning, from the quantitative chemistry question bank, we're going to go over how to do most of them. In each case, we're going to look at each type of calculation 3 times. The first one I'm going to do myself, mostly to work it through and give you a bit of a worked example. In the second one, we're going to kind of do it together, line by line. And then in the third one, I'm just going to give you the answer and you're going to work it out for yourselves. So let's get started. So we'll start with the kind of simplest ones. We've got how many atoms are in 0.2 moles of atoms. So I know that 1 mole equals 6.02 times 10 to the 23. So if I had, say, 2 moles, that would be 2 times 6.02 times 10 to 23. So if I have 0.2 moles, it's going to be 0.2 times 6.02 times 10 to the 23. And realistically, whatever number it is, you just times it by Avogadro's number, which is at 6.02. So when I put that into my calculator, I get 1.204 times 10 to 23. And then that one is done. When I have a look at this one, so where are we? So what I'm going to ask you to do is to try that one yourself. This one's so simple, we're only going to do 2 examples, so try that one yourself. So pause the screen, try it yourself, and then I'll work it through. Okay, so you should only be listening now if you have done this question. It will be 7.1 multiplied by 6.02 times 10 to 23. Put that into my calculator. And it gives me 4.2742 times 10 to 24. Okay, next up. That's it. We don't need to say any more of this. This is where things start to get a bit more complicated because there's multiple steps here. So first, I can see that I've been given a mass, and I can see I've been given a specific substance. So in this one, it was how many atoms, and it's just like a very generic, very general. It doesn't tell me any particular substance. Whereas here, I've been given a particular substance, and importantly, it's asked me for how many ions there are. So the first thing I want to do is turn this number 30.7 into moles. So step 1 is going to be moles equals mass over mR, which in this case is 30.7 divided by the mR of TiCl4. I get my periodic table, and I know that titanium is 48. So I go 48 plus, and then I've got 4 lots of chlorine, which is 35.5. I plug that into my calculator, and I get 48 plus 4 lots of 35.5. That will give me 190. So I get 30.7 divided by 190, and that gives me 0.16157, etc. And I want to try and keep as many decimal places as I can for the minute. Step 2 is to turn that into a number of things, and I use Avogadro's number for that. So this is how many moles of TiCl4 I have. But when I multiply that up by that Avogadro's number, I get 727 times 10 to the 22. That's how many TiCl4s I have in total. And if I sort of imagine, it's not quite accurate, but if I imagine that each one of those looks like this, where a Ti and a Cl and a Cl and a Cl and a Cl like that, and they're all ions, okay? That means that in each one of them, I've got that many of them, right? So I've got 9.127 times 10 to the 22 of these. And if each one of these is an ion, so Cl minus, Cl minus, Cl minus, and Ti4 plus, then in total, I have 5 ions here. So what I need to do is multiply that number by 5. which gives me 9.127 times 10 to the 22 multiplied by 5. And that would give me 4.86 times 10 to 23 ions. So again, just to overview those steps, first I work out the number of moles, and that tells me that I've got 0.16157 moles of TiCl4. I multiply that by Avogadro's number, and I now know that I have 9.1 times 10 to 22 of these. So all of these, this entire thing, and each one of those things has 5 ions in it. And because each one has 5 ions, I have to times it by 5, and that's what I get. Let's try the next one together. So step 1, what I want you to do is pause your video and work out the moles for me, please. Okay, so I'm going to do moles. You should only be listening now if you've actually done this. Moles is mass over mR. Where are we? So moles is 74.7 divided by the mR of Ca3P2. So Ca is 40. So it's 3 lots of 40 plus 2 lots of phosphorus, which is 31. When I run that through my calculator, I get 120 plus 62, which is 182. So I'll do 74.7 divided by 182, and that will give me 0.41 times moles of Ca3P2. And note how much working I'm doing here as well. Clear working gives you clear thoughts. So I'm going to do 0.41 now times by Avogadro's number. And again, I'm trying to keep as many decimal places in my calculator as I can. I'm not rounding yet. 2.47 times 10 to the 23. And again, in this one, Ca3P2, again, there's going to be 5 ions. So I'm going to do 2.47 times 10 to 23 multiplied by 5. That gives me my final answer, which is 1.24 times 10 to 24. So hopefully you got that. And then the final one is over here. And I'm going to let you work this one through yourself. So pause the screen and work that one through. And then hopefully you're getting an answer of 2.39 times 10 to 24. If you did not get that, I suggest you go back to the working like this. Note that in this case, we're not going to be timesing it by 5, but we've got Li2S, which means we're going to be timesing it by 3 because it's got 3 ions, it's got 2 Li pluses and 1 S2 minus. So remember that one gets times by 3 instead of 5 in step 3. Great, let's move on. Let's have a look at this one. So just have a read first. Okay, so in a question like this, we have a few really straightforward steps. You can go back to the video about reacting masses if you need to. I'm going to sort of summarize that, and we're going to do first moles as ever is mass over mR. So in this case, I've got 73 grams of O2. So I'm going to do 73 divided by 2 lots of 16, and that will give me the moles of O2. So 73 divided by 32 gives me 2.28125 moles O2. Step 2 is always to do the ratio. In this case, I've got to go from O2 over here to H2O over there. So my ratio of O2 to H2O is 1 to 2. So I'm going to take this number from here and put it down at the bottom there. That's going to be 2.28125. And to get to 2, I just multiply that by 2. It's a very straightforward ratio. And I get 4.5625. There's an entire video about ratios. So if you're not sure how I did that, make sure you go and check those out. And that means I've got that many moles H2O. And I now just need to finish it off by working out the mass, which is the moles multiplied by the mR. So in this case, it's going to be 4.5625 multiplied by the mR of H2O, which is 2 plus 16. Then my final answer there is going to be 82.125 grams. Done. Next one, we're going to do this again slowly together. So first I want you to do step 1, which is moles. So pause the video, work that out for yourself, please. Okay, so you should only be listening now if you've worked this out, and it'll be 82 divided by its chlorine, so it's going to be 2 lots of 35.5. So 82 over 71 gives me 1.1549, etc. My ratio is a bit more sophisticated this time because I've got to do Cl2 to FeCl3, which in this case is going to be 3 to 2. So this number here needs to come down to the bottom there. So it's 1.1549, etc. This is a slightly harder ratio to deal with. So I'm going to divide by 3 to get 1, and I'm going to times by 1.1549, and I'm going to do exactly the same on this side. And that is going to give me 0.76995, etc. Now step 3 is going to be to work out the mass. So pause your video and do that now. Okay, so hopefully you've done mass equals moles times mR, which in this case is going to be 0.76995 multiplied by the mR of FeCl3, which is going to be Fe is 56 plus 3 lots of 35.5. And that should give me an answer of about 125.11 or 12 grams. Hopefully that's what you got on that step as well. Last one, try this one. Have a go at that entirely yourself. So pause the video, try it yourself. So you should only be listening to the video now if you finish that, and your final answer should be 17.2 grams or thereabouts. If you didn't get that, again, go back to here, look carefully at the working. You might have gone wrong on the ratio step. So remember here that my ratio is LIF. Sorry, come on, hang on, there we are. Is LIF to ALF3. Sorry, ALF3. So that's 6 to 2, or dividing by 3. So make sure that you've got that ratio sorted. Otherwise, you will have gone wrong somewhere. Cool. Next up. Okay, in this case, we've got to go from some masses to a balanced equation. And we have a number of steps to do this. So step 1 is always to work out moles. So what I like to do is I like to lay out, sorry, actually, let's slow it down. Sorry, my bad. I'm going to write out the equation again. So I'm going to do Li, F2, and LIF, like that. Obviously, that's not balanced. So step 1 for me is to always work out the moles, which is going to be mass over mR. So for lithium, I've got 92.4 divided by the mR of lithium, which is 7. And that gives me 13.2. For fluorine, I've got to do, where is it? 250.8 divided by 2 lots of 19. Which will give me 6.6. And then for LIF, I've got to do 343.2 divided by 7 plus 19, which is 26. Sorry, I'll write that in full just so you can see really clearly what I'm doing. And that gives me 13.2 again. Step 2, and you can do that in more steps than that. I've just like done it quite quickly here. But the next step there is to turn it into a whole number ratio. So I've got these 3 numbers of 13.2, 6.6, 13.2. It might be obvious to you what the whole number ratio is there, but there's a very simple trick, which is to divide everything by the smallest number. In this case, the smallest number is 6.6, smaller than 13.2. So I'm just going to write that there. And when I divide all of those by 6.6, this becomes 2, this becomes 1, this becomes 2. So you write out the equation. So that's now 2Li plus F2 forms 2LiF. Step 4, final step, is the most important one, is to check whether that's balanced correctly. And I can have a look and I can see, right, well, I've got 2 lithiums here and I've got 2 lithiums there. So that's right. I've got 2 fluorines here and I've got 2 fluorines there. So I know that that is correct. And if that doesn't balance, then I know that I've made a mistake somewhere. Okay, so those are the 4 basic steps for this one. Let's have a look here. So what I'm going to do is first I'm going to write it out. FeO2 and Fe2O3. A reminder that step 1 is to work out moles. Pause the video now and work out the moles. Okay, you should be listening now if you've worked out those moles. So we'll get moles is 1299.2 moles is mass over MR of iron, which is 56. And that gives me 1299.2 divided by 56. That gives me 23.2. For O2, I'm going to get 556.8 divided by 32. Which will give me 17.4. And for Fe2O3, I'm going to do 1856 divided by 2 times 56 plus 3 times 16. So that's going to be 2 times 56 plus, what is that? 3 times, sorry, not, 16. It's going to give me 160. So 1856 over 160 gives me 11.6. Hopefully I did that calculation right. I'm a bit worried. Yeah, okay, let's see. 2 is the ratio. So I'm going to write those numbers out again just to make my working really clear. Sorry. 17.4 and 11.6. I'm going to remember the chemist's trick of dividing by the smallest number, which in this case is 11.6. So I'm going to get a 1 over there. And I'm going to get 1.5 over there. And I'm going to get a 2 over there. That's still not a whole number ratio, but it's a lot easier to see what I need to do to that to turn it into a whole number ratio, which in this case is just going to be timesing by 2, 4 to 3 to 2. So I'm going to write out my equation, which is 4Fe plus 3O2 forms 2Fe2O3. I'm then going to check. Oh, I've run ahead here. I've not made you do any steps. Sorry about that. Check, pause the video and check that I've balanced that correctly. And I'm hoping what you're seeing is I've got 4 Fe's here, 4 Fe's there. That's 4 there, 4 there. And here I've got 6 oxygens, and here I've also got 6 oxygens. So happy days. Now I'm going to ask you to do then is because I screwed up then I didn't give you enough weighting. I want you to try this one by yourselves, and then I'm going to do all the working to show you what I've done, and hopefully we'll get the same answer. So I'm going to pause the video and do that now. Okay, you should only be listening if you've done the whole thing. I've got S, F2, SF6. First I want to work out moles, which is going to be 22.4 divided by sulfur is 32, I think. Yep, 32. Oh, not 35, sorry, got that wrong. 32, and that gives me 0.7. Now for F2, I've got 79.8 divided by 38, which is 19 times 2. Gives me 2.1. And then for SF6, I've got 102.2 divided by 32 plus 6 lots of 19, which is 146, which gives me 0.7. So I next need to do my ratio, which is 0.7, 2.1, 0.7. I divide by 0.7, 1, 1, 3. I'm going to get 1s, well, I don't need to write the 1, so I'm just going to write it as S plus 3F2 forms 1 SF6. I want to check. So there's my equation, sorry. And now I want to check. So I've got 1 sulfur here. I've got 1 sulfur there, which is great. I've got 6 fluorines here, and I've got 6 fluorines there as well. Happy days. Next up, I think this is the last round that we're going to do. I've got to do excess and limiting. Now, the method that I always use for these is called the have-need method. So I draw my table like this. Have, need, and I get rid of this box. I'm never going to need this box. I put my 2 reactants at the top, Fe and O2 over there. And first I want to work out how much Fe I have in moles. So my moles is 85 divided by 56, which is 1.518 or thereabouts. How much O2 do I have? 95 divided by 32. This is all just using information from the question. Yeah, I'm not doing anything beyond that at the moment. I've got 2.969-ish. Now the question is, if I have 1.518 moles of iron, I appreciate that I've got 2.969, but how much oxygen, but how much do I actually need? How much oxygen do I actually need? So to work that out, I use the ratio. And I can see that the ratio in the question here is 4 to 3. So if I said, I'll do this one over here because it'll be a bit easier to see. If I've got 4 Fe to 3 O2, and I've got 1.518 over here, I divide through by 4 and times by 1.518, and I do exactly the same thing over here. So I'll do put that number back into my calculator one more time. So it'll give me 0.1138. So that, using the ratio, which is what I've done over here, gives me that final number, which is 0.1138. Now, what that means, and you should always write a sentence like this at the end, is I have more O2 than I need. If I have 2.969, but I only need 0.1138, I've got more oxygen than I need. Therefore, it is excess. Done. Lots of marks in the exam. And this table really, really helps me because it helps me see exactly what I've got, exactly what I need, and whether or not I've got more than I need or less. Let's have a look at this one. So I'm going to draw out the table for you first. So we've got lithium reacting with F2, have, need. First thing I want you to do is just work out how many moles are going to go in there and how many moles are going to go in there. You don't need a ratio, you just need information from the question. Pause the video, do that now. Okay, so what you should have is for lithium, you've got mass, which is 94 divided by 7. Sorry, pen's being weird. There we go. 94 divided by 7 is 13.43. Whereas for the fluorine, I've got 50 divided by 38, which gives me 1.3157. Hopefully you got both of those right. Next up, I want you to use the ratio to work out what goes here. Remember, you're going to use this number in the ratio to work out what goes there. Pause the video now. So I'm hoping what you did is you had Li to F2. You have a ratio of 2 to 1, which means if this is 13.43, this one has to just be divided by 2. Which gives me 6.715. Hopefully that's what you got. Now pause your video. Do you have more fluorine than you need, or do you have less fluorine than you need? Pause and write it down. So I'm going to write, I have less fluorine than I need. And I now want you to pause the video and tell me, does that mean the fluorine is excess or is it limiting? So I'm hoping that you wrote, therefore, F2 is limiting. Done. Let's do one more. And what I'm going to ask you to do is run it through yourself, and then I'll show you my working. Pause the video, do it yourself. Okay, so I'm ready to work through this now. I've got Al, I've got Cl2, my table, have, need, kill that. So for aluminium, I've got 64 divided by 27, which gives me 2.37. And for chlorine, I've got 19 divided by 71, which gives me 0.2676. My ratio is what's going to go over here. So I'm going to do Al to, Al to Cl2 is going to be 2 to 3. So if I've got 2.37 over there, my ratio to the other side is going to be 3.55. And again, you can do that however you like, but one clever route is just to go divide by 2 to get to 1, and then times by 2.37. And that'll give you 3.55, which means for sure I have less Cl2 than I need. So it is limiting. So well, therefore it is limiting. I think that's all of them. Great. So that's the end of the video. If there are any that you're stuck on, just go back into the playlist and watch those videos through again. But hopefully that working and that methodology is clear enough for you to be able to answer any of the questions that your teacher might be setting. Have a great day.